সকাল 6টা থেকে 8টা। ওকে, প্লিজ একটুখানি হ্যাঁ একটু
ওকে স্যার।
প্লিজ আমাকে ওই 6 to 8 AM 6 to 8 AM ওখানে একটু কমেন্ট বক্সে লিখে দাও। অরিন্দম বাসু, তোমার দুখানা বলে তোমার অসুবিধা হচ্ছে।
কোন ক্লাসটা? কাল আজকে বিকালে ক্লাসটা?
আমরা কোনো অসুবিধা নেই, 6টা থেকে করতে পারবো।
সকাল 6টা থেকে 8টা। একটুখানি কমেন্ট বক্সে সবাই লিখে দাও না, তাহলে আমি তোমাদের কাছ থেকে এটা পেয়ে নিই। 6 to 8 AM পরের
ক্লাসটা হবে?
কোনো অসুবিধা নেই কোনো, আমি লিখে দিচ্ছি।
পরের সানডে।
ওকে স্যার, ওকে।
কবে হবে স্যার ক্লাসটা?
সকাল 6টা থেকে 8টা।
কবে হবে? কালকে?
না নেক্সট সানডে। আর যদি তোমরা উইকডেজে করতে চাও মানডেতে, কোনো অসুবিধা নেই, আমি সেটা
মানে বিকেলে হবে না?
হ্যাঁ
আজকে
বিকেলে
হবে না?
আজকে বিকেলে তো হবে, আজকে বিকেলে হবে পরের সানডের যে ক্লাসটা, পরের
ও
সানডে
আচ্ছা।
8টা থেকে 10টা ক্লাসটা আমি সকাল 6টা থেকে 8টা করতে চাইছি। ঠিক আছে, ওকে এভরিবডি, প্লিজ কমেন্ট বক্সে লিখে দাও, তাহলে আমি আমার পক্ষে সুবিধা হয়। অ্যাটেন্ডেন্সটা প্রত্যেকে দাও, আমি কাজ শুরু করি। প্রত্যেকে অ্যাটেন্ডেন্সটা দাও, আর কমেন্ট বক্সে একটু 6 to 8 AM লিখে দাও। শুধু ওকে নয়, 6 to 8 AM লিখে দাও, তাহলে আমার পক্ষে মনে রাখা সম্ভব হবে, সব ব্যাপারটা পুরোটা ঠিকঠাক করে অ্যারেঞ্জ করা সম্ভব হবে। আদারওয়াইজ হ্যাঁ, অরিন্দম লিখেছেন, মিঠুন তোমরা বাকিরা সবাই লিখে দাও 6 to 8 AM। অন্যরা একটু লিখে দাও, আমি শুরু করছি। আগের দিনের ক্লাসগুলো বোঝা গেছে? আরও কোনো প্রবলেম থাকলে সেটা আমাকে বলো। আবিদা, সামরিন, ঋতবান দেব, ঈশান, প্রত্যেকে একটু লিখে দাও 6 to 8 AM। কন্যাকুমারী 6 to 8 AM টা লিখে দাও। তো নাও লেট মি আস্ক ইউ, যারা অ্যাটেন্ডেন্স দিচ্ছ একই সঙ্গে একটুখানি টাইমটা লিখে দাও 6 to 8 AM। চলো লেটস স্টার্ট। digital circuits থেকে I will show you something and then we will enter into 8086 programming, right, today. So today in these sessions my agenda is to execute some other circuits, and then we will learn the basics of who knows 8086, who have knowledge on 8086 or any type of microprocessor or microcontroller programming, any type of microprocessor or microcontroller programming.
Sir, 8085 I know, and some other microcontroller, not 8086.
8085. No, having knowledge of 8085 or any microcontroller will help to understand others. And mainly 8085 it was an 8-bit microprocessor. Now 8086 is 16-bit microprocessor. Architecture wise, a huge difference is there. but the programming wise a little bit difference will be there. Okay, chalo, this will help you. So I will try to give a brief introduction. What is an 8086 microprocessor? But before that, let us implement 1, 2, 3 digital circuits and then enter into it. I was trying to cover at least some circuits. I think my screen has been shared. Let me let us practice. mm, Say a circuit of binary to XS3 decoder. Binary to XS3. Some 1, 2 problems with K-map. Now this time you will do. I'm giving you one problem. So can you see this problem? Can you see this problem?
Yes,
Hello.
sir. Yes, sir.
So let's solve it. Let's solve it. This is one way of expressing four variable. A B C D. So we know four variable Carnot map we have done earlier also last day. A bar B bar, A bar B, A B, A B bar. I have collected this from this say problem randomly from internet. C bar D bar, C bar D, C D, C D bar. So now you can understand this room is for A bar, B bar, C bar, D bar. Here A bar, B bar, C bar, D. A bar, B bar, C D, and A bar, B bar, C D bar. Right? Again A bar B, C bar D bar. Again A bar B, C bar D. A bar B, C D, and A bar B bar, C D bar. Not B bar. This is not B bar. A bar B, C D bar. Now here it is A B. And let me A B, C bar D bar. A B, C bar D. A B, C D, and A B, C D bar. A B bar, C bar D bar. A B bar, C bar D. A B bar, C D, and A B bar, C D bar. And you know, so this means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? So if you have this knowledge, there is no issue, then you can easily do this. Um, First thing is A bar B, C bar D, the first term. A bar B bar D. First term is A bar B C bar D. A bar B C bar D. Which one? Which is the room for A bar B C bar D? A bar B C bar D. This is one. A B C bar D bar. A B and C bar D bar. One. A bar B C bar D. A B C bar D bar. A B C bar D bar. Okay. A B C bar D. A B C bar D. This is A B C bar D. A B C D. This is A B C D. A B C D bar. A B C D bar. And A B bar C D bar. A B bar C D bar. Right? Check. All these fill-ups are okay.
Yes, sir.
So A bar B C bar D. Here A bar B C bar D. A B C B C bar D bar. A B C B C bar D bar. Next A B C bar D. A B C D. A B C D bar. And then A B bar C D bar. This one. Now let's do the covering. We are getting this four ones, right?
Sir, one more variable is there, that A, B bar,
Uh,
C, D.
pardon.
One more mean term is there, A, B bar, C, D. Just la- uh,
A
last
B bar.
before.
Oh, A B bar C D is there. Okay, okay, fantastic. Very good, very good. Thank you. Anyway, I have missed A B bar C D. A B bar C D I have missed. A B bar C D is there. Fine. Very good. So for this one, we'll get F equal to only AB is common. You see, only AB is common. AB plus. Next. Now we can have the covering of this four. Can have the covering of this four, right? So in this four, what is common? What is common? For columns, we are getting A column, A common. For columns, we will get A common, right? Sorry, for rows. For rows, we are getting A common, and for column, we are getting C common. Okay? So this is AC. You see, if you cannot make any covering with a particular min term, if we cannot make any covering, then for a four variable map, it will contain four variables. If you can make it make a two covering means a covering with two variables, then one variable will be reduced. If you can make a four covering means a covering with four variables, then two variable will be reduced. Now that's why you see in place of four variables the terms are with only two variables, because in both the cases we have made the coverings with four variables. Okay, the coverings can be with either two variables or four variables or eight variables, means it should be in 2 to the power, 2 to the power n, right? And the number of variable with the by 2 to the power n, then n variables will be reduced from your expression. So your expression, your circuit becomes much easier, much cheaper. Okay, and again we are getting here one two covering. This one this one is left. Okay, for this we are getting. So what is common? Column wise, B common, column wise B common, and row wise C bar D bar, C bar D. Okay, have you understood?
Yes, sir.
Okay, fine. Now let us draw the circuit. Now you have understood. I have drawn A bar A, A bar B, B bar C, C bar D, D bar lines. Now for the first term with AB. First term is AB. I'm taking a connection from A and then taking a connection from B. This is AB. The next AC. And then B C bar D. B C bar and D. Understood? Hello?
Yes, sir.
Yes, sir.
Achha. Oh, wow. Mm. Okay. Now let us learn another circuit. Different circuits are there. Let us discuss with you about different circuits, combinational circuits, different combinational circuits at least. Every time it is giving so much messages, so many messages. Okay. Now, there are four very important combinational circuits. You have heard probably. Whatever we are doing right now, all these are combinational circuits. Combinational circuits. There are two types of digital circuits, you know, combinational circuits and sequential circuits. Combinational circuits and sequential circuits. In case of combinational circuits, the inputs depend, the output depends on the combination of inputs only. আচ্ছা, যারা নতুন এন্ট্রি নিয়েছো তাদেরও একবার বলে দিই, প্রত্যেকে অ্যাটেন্ডেন্সটা দিয়ে দাও তোমাদের কমেন্ট বক্সে। আর নেক্সট ডে 8 to 10 এর ক্লাসটা আমরা অলরেডি সকলের সঙ্গে কথা বলে ঠিক করলাম 6 to 8 হবে। প্রত্যেকে সেটা লিখে দাও, 6 to 8 AM। 6 to 8 AM কথাটা লিখে দাও আর নিজেদের অ্যাটেন্ডেন্সটা দিয়ে দাও কমেন্ট বক্সে। নেক্সট ডে ক্লাসটা 8 to 10 এর জায়গায় 6 to 8 AM, সকাল 6টা থেকে 8টায় পড়ানো হবে। তো সেটা এখানে লিখে দাও একটু, ওকে? কমেন্ট বক্সে লিখে দাও আর কমেন্ট বক্সে প্রত্যেকে তাদের অ্যাটেন্ডেন্সটা দিয়ে দাও প্লিজ। উত্তমশীল শুধু ওকে স্যার নয়, টাইমটা লিখো, 6 to 8 AM টাইমটা লিখে দাও, তাতে সুবিধা হবে আমাদের সবকিছু কন্ট্যাক্ট করতে, ওকে? প্রত্যেকের কাছে বলছি অ্যাটেন্ডেন্সটা দাও আর 6 to 8 AM ওটা লিখে দাও, ওকে? Combination of inputs. The output depends on the combination of inputs only. Another type of circuit is there that is called sequential circuits. Sequential circuits. In this case, output depends on the combination of inputs. Combination of inputs and the previous output as well. In case of combinational circuits, the output does not depend on the previous output, but in case of sequential circuit, the output depends on the previous output, okay, as well as the combination of inputs. We don't not have to discuss all these things theoretically. Right now we will go for combinational circuits. Some combinational circuits which can be easily implemented in laboratory. So this we will study now. One of these circuits we will take up, combinational circuits. One of those circuits we will take up now. One is decoder. Number 2, encoder. Number 3, multiplexer. Number 4, demultiplexer. Decoder, encoder, multiplexer, demultiplexer. Okay. Right now I am taking Today I will try to discuss on decoder and if possible then on encoder also, because up to 9 o'clock I will continue this one. After that we will enter into 8086. So 2.5 class for digital circuits and 2.5 class for 8086 programming, right? Okay. So first let us take up decoder. Decoder means it you will be given a code and the circuit will decode that. Circuit will decode that. That means uh, so for code input. Let us suppose I have a 2-bit code. I have a 2-bit code. So what may be the different variations of a 2-bit code? How many variations may be there for a 2-bit code? You know, yesterday last we have discussed how many variations of a 2-bit code.
Sir, four variations.
4 variations. Very good. There will be 4 variations, 2 to the power 4 variations. 2 to the power 2. Let us take a 2-bit code. 2-bit code means 2 to the power 2 variations. So we are getting say those are inputs are AB and the output is Y. So variations may be 0 0, 0 1, 1 0, 1 1. Say I need when the output will be 0 0. These are condition. These are particular combination. Then output 1 will glow. I'm writing here O1. Don't confuse between O and 0. So I'm writing in some different way. In digital circuits, when we confuse between 0 and O, normally in case of 0, we write 5. So say O1, output 1, right, will glow. So this is the decoding. So 00 is the code for O1. This is for O0. This is for code for O1. This is the code for O2, and this is the code for O3. Means what? Say these are 4 devices. O0 is device 0. O0 is device 0. O1 is device 1. Understood? O2 is device 3. And O4 is say device 2. And O3 is device 3. That means for our input combination 0 0, for our input combination, for our input combination 0 0, this is the code. Or let me write for an input code 0 0. For a input code 00, device 0 will run or will be activated. Will be activated. Will only, I'm using the term only be activated. Only device 0 will be activated, others will remain deactivated. So activation means one. Activation means what? Here we are meaning activated means 1 and deactivated. Deactivated means 0, right? When you are giving 01 code, then uh, say for acha, I am showing you in some other way. I am showing you in some other way that will be better for you. I feel like to understand. Output 1, output 2, output 3, output 4. This will be activated. Otherwise, you see, when the input code is 00, output 1 is 1, means output 1 is activated, others are remaining deactivated. When input code is 01, then output 2 will be activated. That means device 1 will be activated. So let us take 0, device 1, 2, and 3. So device 1 is activated, others are remaining deactivated. When input code is 10, then you see output 0, output 1, and output 3 are deactivated. Only output 2 is activated. And you see when the input code is 11, then only output 3 will be activated. Only output 3 will be activated. Okay, have you understand? Any issue? Please. Any issue? Please tell me. Hello.
No, sir. Okay.
Okay, fine. Now we will design this circuit. Now we will design this circuit. You don't need a Carnot map. This is very easy circuit. Now you tell me what should be the input combination for O1, for O0. What should be the input combination in terms of min term? Tell me. Very easy.
0 0, sir.
00 means we can write it A bar B bar. Okay. You see, when A equal to 0, A bar equal to 1. B equal to 0, B bar equal to 1. So then A bar B bar equal to 1. Right or not? Understood why I am writing it is A bar B bar? Getting me?
Yes, sir.
So O equal to 0. The code for O equal to 0 is 00. That means this is A bar B bar. This min term is corresponding min term is A bar B bar. For O1, for O1, output 1, what is the input code? What will be the input code for output 1? Please tell me. Please anybody tell me. You can see A equal to 0, B equal to 1 means anybody please respond.
Sir, A bar B.
A bar B. Fantastic. A bar B. O2. O2.
A,
A B
Again,
bar.
please repeat.
sir,
A.
A,
Your voice is breaking, my dear. I cannot listen you properly. But I have understood you have told A B bar. For O3, what is the input?
A, B.
A B.
A B. Very good. Now this is the satisfaction of a teacher. The when students can answer, right? This is the satisfaction of a teacher. Thank you. Now, so here we have prepared A bar and B bar line also. Now, first O0 is A bar B bar. So this is A bar B bar. A bar B bar. That is basically output 0, right? So now we are going to slowly we are going to design devices. Next A bar B. This is A bar B. Next A B bar. And then AB. Then this is AB. Okay. Now let us design this circuit in our. Let us design this circuit in our laboratory copy. Sorry, laboratory copy. I am saying. Let us design it practically. Now, so let us suppose this is A. And this is A bar, right? This one is A, this one is A bar. This one is B, B bar. Now four outputs. This is output 0. This is for output 0. This is for output 1. This is for output 2. And this is for output 3. So what is the combination of output 0? A bar, B bar, right? What was the input combination of output 0? What was the code for output 0? A bar, B bar, right? A bar, B bar. I am connecting the output also. Can you understand how the circuit I'm drawing?
Yes, sir.
So this is A bar, B bar. Okay. Now next is for output 1. This was A bar, B. A bar and B. Okay. Understood? Understood how I have made it A bar, B?
Yes, sir.
For third one, this was A B bar. A B bar. Okay, this is output 2, and for output 3, AB. Now you check when out inputs are 0 0, output 0 is selected. Output 0 is selected. Have you checked? Can you see, please? Please respond.
Yes, sir.
When
Yes, sir.
input combination is 0 0, output 0 is selected. Input combination is 0 1, output 2 is selected. Input combination is 1 0, output 3, output this one is selected. And when output input combination is 1 1, then the last one, oh, last one I have not connected. This one is selected. So again check 0 0, O0 is selected, right? Input combination 0 0, O0 is selected. Input combination 0 1, O1 is selected. Input combination 1 0, okay, O2 is selected. And input combination 1 1, O3 is selected. Have you understood how the code has been decoded? Have
Yes,
you
sir.
understood how the code has been decoded? Why it is called decoder? Because you are giving a code for a particular job. In microprocessor, this will be required. You are giving a code for a particular job. You are giving a code for a particular job, and that particular job is being done using the code only. That particular job is being done. Okay. Now, now it's time to move. I think you have understood how to use the simulator and basics of digital circuits. Now we will move to the other portion, next portion. Okay. Now give me a 1 minute break. I'm coming back. You will get a tutorial documentation of 8086 with the simulator itself. I feel you all have the simulator. You can download the system. Already the number systems we have discussed in these classes. Let us have a little bit overview. Eight zero eight six. I am copying these images from this tutorial already available with 8086 simulator so that you can relate. And this tutorial is also available in internet. 8086. 8086. For the basic introduction, we may say, for the basic introduction, we may say this is an 16-bit. This is a 16-bit microprocessor. This is a 16-bit microprocessor. This is a 16-bit microprocessor. 16-bit microprocessor means already you have got the idea of bits. Already just now we have handled with 2-bit codes. Now 16-bit microprocessor means the number, more is the number of bits, longer is the size of data. That means what is the difference? Someone of one of you was talking about 8085 microprocessor. 8085 microprocessor was a 8-bit microprocessor. 8-bit microprocessor means it could handle 8-bit data. So 8-bit data means, can you tell me what may be the different variations? How many number of words may be possible with 8-bit? Can you tell me how many different variations?
256, sir.
256, right? 256. How we are getting 2 to the power 8? 2 to the power 8 equal to 256, right? For 8-bit. On the other hand, when you are going to 16-bit, this is becoming more or less 654465436 or like that. We call it 64 kb. 2 to the power 16. This is very easy to calculate. This is very easy to calculate. 2 to the power 1 means 2, 2 means 1 means 2, 2 to the power 1, 2 to the power 2 means 4, 2 to the power 3 means 8, 4 means 16, 5 means just multiplying by 2. Just multiplying by 2, 32, 6 means 64, 7 means 128, 8 means 256, 2 to the power 8, 256, 2 to the power 9, 512, 10, 1024, 11 number of say 2048, then 12 means 4096, 4096. It means 4 kb. We are writing it 4k. So 13 means 8k, 14 means 16k, 15 means 32k, and 16 means 64k, right? After 1k you can write this is 1k, this is 2k, this is 4k, this is 8k, in this way. So whenever you are getting 16 bits, that means you are having 64k different variations, 64k different data. Okay, fine. 64k, 64 thousands means six. Actually, basically the number becomes 65,000 something. 65536 like this type of data. Oh yeah, anyway, so 8086. Now, what is the advantage of having a 64-bit 16-bit microprocessor over 8-bit microprocessor? Because in 8-bit microprocessor, the CPU is able to handle 8-bit data at a time. But on the other hand, whenever you are using a 16-bit microprocessor, the CPU is able to handle 16-bit data at a time. That means if you are using 8-bit words, so this can handle 2 word at the simultaneously. So this becomes faster. And a great part of CPU's job is to transferring data from one place to other. You will see. You will see when who have done coding. You please remember your time of coding. In how many times of you have written equal to? How many times you have to write equal to in a coding? In equal to means what? The data is being copied from one variable to other. No, yes or no? Yes or no? Whenever you are writing, you have done C coding. I feel. Whenever you are writing equal to, that means what? The data is being transferred. It is being copied, not transferred, but copied from one variable to other. That means the movement of data, and this movement of data covers the maximum part of the coding. Movement of data, x equal to y equal to z, anything equal to another thing, right? So now this copying becomes too much faster if the CPU can handle more data at a time. Suppose you have each word of 32-bit data. Now, for an 8085 who can transfer 8-bit data, which can handle 8-bit data at a time, it will take four operations, four CPU cycles, four operations to transfer the data from one variable to other. On the other hand, if you are using a 16-bit microprocessor, it will take two operations to transfer the data. And even for 32-bit microprocessor, it will take a single run to transfer the data, right? So these are the advantages of getting more bit CPU. Say at the beginning, when the computers were made up of 80186, 80286, 80386, 486 processor, where DOS would run, those were all 32-bit microprocessors. Now, whatever you are using, all those are 64-bit microprocessors, right? So this is one advantage, that this becomes faster. So now we are using CPU of 8086. 8086, which is a 16-bit microprocessor. 16-bit microprocessor means it can handle 16-bit data. Though it was an after 8-bit, say after 8085 it appeared. So 8-bit microprocessor, 8085 was an 8-bit microprocessor. So it kept some compatibility with 8085. So uh, here the registers. Now we are coming to new terms, registers. You can see it is written AX, BX, CX, BX. You can see it is written AX, BX, CX, GX. Okay, I am highlighting this portion. I am highlighting AX, BX, CX, GX. Can you see AX, BX, CX, GX?
Yes, sir.
These are all 16-bit microprocessors, 16-bit registers. 16-bit, that means it can store AX can store 16-bit 16-bit data, BX can store 16-bit data, CX can store 16-bit data, and DX 16-bit data. But it has came. Remember that it has appeared after 8085, and in 8085 there was our we are familiar with working with 8-bit data. So if I have to transfer those work to this with this microprocessor, then we should have 8-bit register. If not, otherwise the space is being used wasted. So while designing the 8086 microprocessor, it has been kept in my mind that 8-bit operations could be done. The facility should be there. So you can see for AX, BX, CX, and DX, in all the cases, the registers can be separately divided, and can be separately used. AH and AL. L for low, H for high. Means lower order 8 bits can be used. They are named as AL, and higher order 8 bits can be used as another 8-bit register. In this way, AH, AL, BH, BL, CH, CL, DH, DL. Now, a question may appear in your mind as you are saying that AX is a 16-bit register, AX is a 16-bit register, and AL, AH, these are 8-bit register. So when I will ask the microprocessor to uh, fetch data from register A, where from it will fetch AX or AL or AH. Now, thing is that just remember that the instructions to transfer 16-bit data and instructions to transfer 8-bit data are different. Instructions to transfer 16-bit data and instructions to transfer 8-bit data, they are different. So there will be no case of any confusion. If you want to copy the whole content of AX, there is a separate instruction. If you want to copy the content of AL only, there will be a separate instruction. If you want to copy the BH only, there will be separate instruction. Okay. So these are, let us just give an introduction only, because that I cannot do in this class. It's a very short time class. So AX, BX, CX, and DX, these are all 16-bit register. This can be done in 8-bit also. You can use two 8-bit registers also. This one is called flag register. This one is called flag register. This one, and flag is for what? To show the user or to show the next operations. What was the, because all the operations, all the operations are here separate, individual, isolated. Means there is no relation between the first operation and the second operation and the third operation. When the second operation is happening, the second operation does not require any data. The second operation is happening, it does not have any trace of the first operation. I'm using a wrong word. When the second operation is happening, the second operation does not have any trace of the what happened in the first operation. In the instruction there is no, but we should make some link. Suppose you are doing an addition. You are doing an addition bit by bit. Try to suppose you are doing an addition like 3 5 plus 7 9 in decimal. Now when you are adding this 9 and 5, you don't need to know if there was any previous carry or not. So you are adding 9 plus 5 14, but now one carry appears. What should be added to the next, during the next addition? 3 plus 7 10, it should be 11, right? Understood this thing? This
Yes, sir.
carry. Okay. When you are adding 5 and 9, no information of carry, if there was previous carry or not, was required. But when from the next bit onwards, from the next digit onwards, every time you require, if there were any carry has occurred in the previous operation. So the instruction must have this advantage, so that it can know what happened in previous operation. If a carry was generated, if the carry was 0 or carry was 1, this knowledge is required. But where this operation will leave this mark, if some carry has occurred or not, the first addition operation, where it will leave the mark if some carry has occurred or not, for the because second operation needs this knowledge, that if some carry has occurred or not in the first operation. And for that purpose, flag registers were there. Oh, these are CSCI. Oh, sorry, I'm sorry. This is not flag register. This is not flag register, and I've wrongly shown you. This is not flag register. This is flag register. Earlier, the classes were 6 hours long. At that time, it was easy. This is the flag register. Okay. This is the flag register. You can see this is a 16-bit register. This is a 16-bit register. Only 14 bits have been used. So here there is a particular flag called carry. So whatever result is coming, after addition, the result means in terms of carry. If the carry is 0 or 1, that has been stored in this bit. So the next addition operation checks here if the earlier operation has generated any carry or not. It can check it from here. Understood? Understood what is the role of flag register?
Yes, sir.
So I have discussed about only one flag because I cannot discuss much more. I have discussed about only one flag. There are so many other flags are there, like parity. You see, after carry, there is a flag called parity. Parity means if the number of ones in the accumulator. If the number of ones in the accumulator means A register, AX is called accumulator. AX is accumulator. Okay, this is accumulator. This is accumulator. This is accumulator. This is accumulator. Okay. So accumulator. Now, if the number of ones in accumulator, they are in even number or odd number. They are in even number or odd number. If they are even number, that is called even parity. If the number of ones in accumulator becomes there of even number, then the parity flag is set. Set means becomes 1. Then the parity flag becomes set. If the number of ones in accumulator is odd, then this parity flag, this means odd parity. That means odd parity. The parity flag is reset. The parity flag is reset. Okay. If the number of ones in the accumulator is even, then it is even parity. So the parity flag is set. If the number of ones in the accumulator is odd, then it is odd parity, though the parity flag is reset. Now, what is auxiliary carry? Auxiliary carry. Let us understand what is auxiliary carry. Auxiliary carry. You know, for an 8-bit addition, say, suppose this number was 10111100. Can you tell me what is this number? Can you tell me what is this number in hex? In hex, this means, acha, let us take a small number. Let us take a small number so that you can easily evaluate. 0111 10. No, I will not take one here. 0101. So this means this is what? This is what? This is 7, right? And this is 5. So in hex, this is 7 5, and in any microprocessor system, we always use hexadecimal number system. Hexadecimal number system, and we are adding another number, say 0110 0110 and 0011. 0110 means this 4 plus 2 6, and this is 3. That means 6 3. So when you are adding this number 3 plus 5, 3 plus 5 is 8. Okay, and 3 plus 7 plus 6. Now for next addition, no carry is going. No carry is going. So a microprocessor can add at least 8-bit numbers. So 8-bit numbers, there are two nibbles. These are called two nibbles. A 4-bit section is called a nibble. A 4-bit section is called a nibble. Nibble. When a carry is being transferred from one nibble to another, then we call it an auxiliary carry. Like this, suppose the numbers are 7, 8, and 3. What do you say? 3, 9, 3, 9, 7, 8, and 3, 9. Can you tell me what is the result? 9 plus 8 equal to? Can you tell me in hex? Remember that you have to do in hex. 9 plus 8 equal to?
7.
After, huh?
Only 7 because
Let me
9.
check. 9 plus 8. 9 after 9. A, B, C, D, E, F, 0. Right? 0, 1. 9 plus 8 equal to 1. Understood? After 9, A, B, C, D, E, F, 0, and then 1. 1, 2, 3, 4, 5, 6, 7. Understood? How it is coming?
Okay. Yes, sir. Yes.
As it is crossed F, as it is crossed F, and carry has been generated. And carry has been generated. Understood? As in case of decimal system, when we cross 9, because 9 is the last digit in decimal system, right? 9 is the last digit in the decimal system.
Yes, sir.
In the decimal system, we are getting 0 to 9. And in an hexadecimal, we are getting 0 to F. So what is the system? Try to understand. When we cross 9 and carry is generated. So in case of any hexadecimal system, when we cross F, a carry is generated. When we cross F, a carry is generated. Right? Okay. So here we have crossed F, so a carry is generated. And it becomes 3 plus 4 or 7 plus 1, 8. 8 plus 3 means 9, A, B. B. So the result is B1. Now, when the carry has been transferred from one nibble to another, this is called auxiliary carry. Okay, understood? This is called auxiliary carry. Understood?
Yes, sir.
Okay, fine. One minute. Okay. Now let us understand these registers. The memory size, of 8086 is 20 bits. The memory size of 8086 is 1 MB. So at number of addressable places, number of addressable places is uh, number of addressable places is 2 to the power 20. Number of addressable places is 2 to the power 20. Right? 2 to the power 20. But it has only 16 address lines. No, sorry, that's 20 address lines. Now, the question is, so 20 address lines. It has 20 address lines. The 16-bit microprocessor, that means max size of registers is 16 bit. Maximum size of registers is 16 bit. But it has 20 address lines. 20 address lines means address are 20 bit. Address are 20 bit. I know maybe you are facing huge problem. I know. But I am also helpless over here. I am trying to tell you as minimum as possible because of time limitation. Earlier, when we would got say 6 hours of classes, we could we could explain in more vivid way. And I know whenever somebody is listening the name of 8086 first time, so it is a tough thing for him or her to understand what is address line at all. What is address line? First time today morning, first time only a 1 hour ago, he or she has learned the term decoder, right? Now he sees lining address line. If you have not prepared from earlier, I know this is tough. Please make questions so that I can reach to you. Please make questions whenever you are facing any issue. You are facing issues. If you are attentive to the class, you are facing issues. I'm sure. I'm sure. But if you can ask me, then I can reach to you. I can try to solve your problems, at least as much as it is possible. Address lines are 20 bit. And again, it is not a theory class. Still, I know that if I don't discuss a little bit of theory, I cannot show anything. You cannot, everything will be go out. I mean, just a tangential 20 bit. Now, the question is how a CPU handles a 20 bit address with 16 bit registers, because it has to manipulate, it has to do arithmetic on address also. Address means the bit pattern. What is address? Address means a bit pattern to select a particular memory location. Address is what? Address is a bit pattern to select a particular memory location, right? So these are 20 bit. And 20 bit means, can you tell me what is the size of memory, size of addressable memory for 8086 CPU? Can you tell me what is the size of addressable memory? This is 2 to the
1
power
megabytes.
1 megabyte. Fantastic. Very good. This is 1 megabyte. 1 megabyte. 1 MB is the size of CPU. And you know, in hardware section, we can do huge with 1 megabyte memory. We can do huge with 1 megabyte memory, right? Now, a 4 KB program is a huge program, right? A 4 KB or 8 KB program is a huge program. So 1 megabyte, a huge memory, right? Now, what it does 8086 does 64 KB sections, 64 KB sections of different sections for 1 megabyte memory. It cannot use 1 megabyte memory at a single run. At a single run, it divides the say what I say. Okay, I think I want to clean this section. I want to clean this section. But I need also this portion. Okay, let me see what I can do. Now, this 1 MB memory, 1 MB memory has been divided. 1 MB memory has been divided. Has been divided into several 64 kilobyte segments. several 4 kilobyte segments. During a particular execution, during execution of a program, execution of a program, what is required is number one, code segment, code segment. In 8085 there was no such segmentation, but in 8086 there is so. There was a code segment where you keep code. Number two, there is a data segment to keep required data. Though in small programs you can have one segment and do everything, that also you can do. And in our programs we will do in that way only, data segment. Number three is what? Stack segment. Stack segment. And stack segment, what is to keep stacks. You know what is stack. I think you know what is stack. You know though, everybody? You have done C
No,
programming.
sir.
You don't know what is stack?
No,
You
sir.
know what? Yes or no? I have not understood. Yes or no? What is?
No, sir.
No. Oh my God. You have not done C programming? You have not data structure? You have done or not? Data structure?
No,
My,
sir.
my God. Another is extra segment. Stack is something that is a data structure that is required for executing function calling. This is very much required. But why it is required, how it is required, if I want to explain it, it will take 2-3 hours. 2-3 hours with a program segment. Have you done any type of coding at all? Plus tell me, have you done any type of coding?
Sir, I am learning C.
You are learning C, only you. But by course wise, you have not done any type of coding?
Sir, in 12 I had to HTML basic.
HTML is not a coding. HTML is scripting. HTML is not coding in that way. It's scripting basically. Do this thing, do this thing, and hardly there is a decision making thing type of thing. Hardly there is used matrix, any array. Okay, so let us see. I have to show you some circuses then. I have to show you some circuses. Okay, chalo. Let's do extra segment. So I'll show you some codes because whatever I will try, it will not be successful. I can understand. I will want to show you some program structure. So this is extra segment. In extra segment, you can use for any purpose. So here also address starts from like this is a locality. Here also address starts from 0000. In hex, I am writing in hex because all are here. These local codes are all 16 bits because this can be handleable with the with the 16-bit register inside the CPU and start ending at FFFF. FFFF. Everywhere these are local address 0000 and FFFF. We call it offset. We call it offset. Like this is not so tough thing here. This is not so tough thing. Suppose in a locality there are say 1,000 houses, so 100 houses, but you are having only a 2-digit number plate. You are having a 2-digit number plate, but there are 100 houses, but you do have say 2-digit number plates. Okay, what you will do, বলো তো আমার সঙ্গে আমার ডিসকাস করো তো। একটা বাড়িতে এটা 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 বুঝবে, তবেই সেগমেন্টেশন বুঝবে। একটা বাড়ি, একটা লোকালিটিতে তৈরি হচ্ছে, লোকালিটিতে একদম মানে ব্লক ওয়াইজ সুন্দর করে, লাইক সল্ট লেক, it is being developed, right? There are so many lanes, so many rows, and now it is being developed. So you want to give the numbering of each house by 2 digits, because you understand that remembering a 3-digit number, it will be tough. So you will be every house will be given a 2-digit numbering. তাহলে কিভাবে করবে? 100টা বাড়ি আছে, 100টা বাড়ি আছে। ও না না, 100টা বাড়ি 2-digit নাম্বার না, আমি বলছি সে 3-digit নাম্বার। 1000টা বাড়ি আছে, 1000টা বাড়ি, রাইট, সরি, আই এম সেইং 1000 houses are there, 1000 houses। কি করে করবে বলো? And you are having only 1,000 houses, means you need 0000 to 9999, all those 1,000 numberings, 3-digit numberings। বুঝতে পারলে কি পারলে না? হ্যালো, এটা তো সিম্পল কেস, এই কথাটা বলতে পারো?
Yes, sir.
তাহলে আমরা কি করব, এই পুরো লোকালিটিটাকে 10টা রোতে ভেঙে নিচ্ছি, 10টা ব্লক, ব্লক এ, ব্লক বি, ব্লক সি, ব্লক ডি, ব্লক ই, ব্লক এফ, ব্লক জি, এরকম করে চলছে। 10টা ব্লকে ভেঙে নিলাম, আর প্রত্যেকটা জায়গায় নাম্বারিং শুরু হচ্ছে 00 to 99। তাহলে হবে 1000 খানা বাড়ি। বোঝা গেছে?
Yes, sir.
So segment block A means here segment A, এটাই হলো segment। segment A এর থেকে শুরু করে অফসেট 00, মানে ফার্স্ট বাড়িটাই অফসেট 00, মানে ফার্স্ট বাড়িটা, 01 মানে ফার্স্ট বাড়ির পরের বাড়িটা, একটা বাড়ি পরে, 02 মানে দুটো বাড়ি পরে, 03 মানে তিনটে বাড়ি পরে। সো দিস ইজ অফসেট। বোঝা গেল হোয়াট ইজ সেগমেন্ট এন্ড হোয়াট ইজ অফসেট? ক্লিয়ার হলো বাবা?